Hey guys, this is Ed from Barnabas Robotics. I want to take just a little time today to talk about one of my favorite topics, the breadboard. So one of my students, Naomi, if you're out there watching, hello, good to see you, hope you're doing well. One of my students, she was looking at one of her old projects and wanted some tips on how to fix it. So I thought, hey, you know what, let's make a video and let's share it with everyone so that maybe you guys have projects that you need to fix as well. You need a little refresher. Okay, so breadboard, what is it for? Breadboards are used by electrical engineers to connect wires together. So what we're going to do right now, I'm going to just talk about this right here. This is a little fan project that I have here. We're going to talk about how to get this motor running first, and then we're going to talk about how the breadboard helps us make connections. All right, so let me move over here, and this is my whiteboard. Okay, so let's talk about first this motor right here. So this motor, it's a DC motor. It's got two wires. We got a purple one and then also a gray one. All right, and then we have a battery here that's inside a battery holder, and we have black is connected to the minus side of the battery, and we have red connected to the plus side of the battery. All right, so let's see if we can figure out how to turn this thing on. So on the whiteboard here, what I'm going to be doing is drawing a schematic, which is basically a map for the electricity flow. All right, so I'm going to draw my battery. I always use a heart. Battery has a plus and a minus, and then we connect it. I'm going to draw these two wires. Red is the plus, black is the minus, and then the DC motor I'm going to draw here. Okay, and it also has two wires coming out. All right, so right now this is what we call an open circuit because there's an opening. There's actually two openings in here. So if any circuit here has more than or has one or more openings, it's going to be an open circuit because electricity needs a closed path in order to flow. All right, so what we do is this: we connect one side here, one side here. What you get then is you get flow of electricity all the way through. Everyone's happy and the thing turns on. So let's see this, okay? So if I take the black wire, connect it, I'm just going to use my fingers here, just pinch it. And then over here, the red wire, I'm going to pinch it. And you see it's moving, right? Okay. So that's easy enough. Now, what if we want to make the circuit so that we don't have to hold it, right? Because earlier I had to pinch it. That doesn't make sense, right? So as electrical engineers, when we're making circuits, we want to make it so that we design it and then we put it in there and it stays there. So this is my breadboard here, okay? And I'm going to lift it up for a second. So looking at this breadboard, you see there's two main sides. All right, you got this column right here and this column right here, and then we have this valley down the middle. I'll explain what that valley is in a second, but first let's ignore this side. I'm covering with my finger, and let's just look at this side. Okay, so if you look at this, we have all these holes, and if you look closely, the holes, they're in rows of 5. So rows go side to side, right? So like this top row here, row number 1 has 1, 2, 3, 4, 5 holes. All right, if you go all the way down, I think there are 17. I think I got that right. 15. I may not remember it exactly right. 15 or 17 rows going down. Okay. So here's the thing: if wires are on the same row, those wires are connected. All right, so let me explain. So again, we're just ignore that part for now. Okay, so we have, let's say I put a red wire right there. If I want to connect it to the purple wire, okay, if I want to connect it to the purple wire, I could put it here. These are on the same row, so those two wires are automatically connected. So this here is the same as me going like this. all right? The benefit is that I don't have to do that. The breadboard can help me do that. So I'm gonna put it here and put it there. So those are connected. Now, here's the other kind of tricky thing. You see there's all these options. So this is on the same row here. So that hole works. I could also put it on this hole. That works. I can also put it on this hole. That works. So as long as it's on the same row, then those two wires are connected. Now, if I don't want these two wires connected, I could put it down here. See, different rows, they're no longer connected. I could get kind of tricky, and I could put it right here. It's really close to the same row, but not quite. You see the purple one's on row number 2, and this one is on row number 1. So those are not connected. All right? Now, what's the deal with this side? The reason I wanted to ignore this part first is that if I go like this, guys, let's say I go row number 1 on that side and row number 1 on this side, they're on the same row, right? Purple's on the row number 1, red's on row number 1. They're on the same row, but they are not connected right now because they are separated by this valley. So I call this valley the valley of death, all right? Connections or electricity, they don't travel past the valley, all right? So in order for it to actually be connected, it has to be on the same side of the valley of death and on the same row. Just make sure you're listening. I could put it here and then move it on this side. Those are also connected because it's on the same side of the valley of death and on the same row. All right? So that part gets a little tricky, but just so you guys know, okay, so now we have some background on how a breadboard works. Let's use the breadboard to turn this thing on. Okay, so going back, looking at our circuit here, we have the plus. I already have it here. So the plus of the battery is connected to, and I'll put it here so we can kind of see it. So the plus of the battery is connected to one of the motor wires. Now the minus of the battery, let's make a new row. I put it down there. I think it's row number, what is that? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Yeah, row number 6 on that side. All I gotta do is put it on the same side of the valley and the same row, and I have connections. Okay, so you see what happened there. What's nice is that now my motor is on, but I don't have to hold it with my fingers. Okay, let me disconnect. Let's make an open circuit, and let's talk about this guy. Okay, this is a 4-pin button. All right, you can't quite see it as well, so I'm going to draw it on the whiteboard over here. Okay, so let's look at. This is my. Let me update my color here. This is my button here. All right. Here's the first thing I want to say. When we're working with the button, we want to make sure that the legs are on the sides. You could also turn it so that the legs are up and down like this, 2 on the top, 2 on bottom. That's going to confuse you. So we don't want that, okay? When we're working with the button, make sure the legs are on the sides. Now, there are 4 legs, right? We have 1, 2, 3, and 4. Here's the thing about the legs. Legs 1 and 2, they are actually connected, so kind of like the breadboard, same row, they are connected. 3 and 4, these are also connected. All right? So I'm going to call this top one is A, and this bottom one is B. All right, so A is a connection, B is a connection, but A and B, they are not connected unless the button has an unless. Unless you press the button, when you press down on the button, you actually, well, here, click on these guys. I'm drawing a dash because it's only sometimes. It's sometimes connected because when you press the button, A becomes connected with B. So what the button allows you to do is sometimes you can make a connection between A and B, and sometimes you can make an opening between A and B. Okay, so how does that help us? Well, check this out. I'm going to draw my circuit again. All right. Now this time I'm going to add a button, and this is what I'm going to do. Here is my button. I'm going to connect one leg of the motor to here, and the minus to here. And I'm going to draw these connections. You remember the top legs are connected and the bottom legs are connected. So what happens is that when it's like this, when we don't press the button, what happens is that you have electricity trying to go, and it's trying to go back to the minus, but look, there's no path right here. It gets stuck, so the motor does not turn on. So I'm going to draw a little table here, okay? Here's button and motor. So when the button is not pressed, what do we get? When the button is not pressed, the motor is off because we just saw that it gets stuck there. But when we press the motor, what happens? It goes here, and then it's trying to get down. Now the top row becomes connected to the bottom row, so that means I can get all the way through. People are happy, everyone's happy, electricity comes through, and the motor turns on. And that is how you use a button to turn a circuit on and off. So let's try to build this same circuit using this schematic. So I'm going to change it to the ultimate view here. All right, so I got my schematic up here. You can see the motor here on the side and a top-down view. All right, we got all things going here. All right, so let's start over. Let's move these aside. All right, let's start with the plus connection of the battery. So the plus connection, remember, is the red of the battery. I'm going to start over here, so we give ourselves some room here. Okay, that's the plus of the battery. The plus of the battery is connected to one of the wires of the motor. So you can pick any wire. I think I was using purple before, so I'll use purple first, but it doesn't really matter for DC motors. You can use either wire, okay? So right now, the plus of the battery is connected to one of the motor wires. Now the other motor wire, meaning for me, it's this gray one right here. The other motor wire connects to the top row of the button. All right. So I'm going to take my button, and I'm going to put it like right here. And notice how I put it so that the legs are on the sides, right? Remember, we don't want the legs up top. It's going to confuse us. So the legs are on the sides, and the row A of the button and row B of the button are on different rows. All right? All right, so now what did we say? We said the other wire of the motor, which is this one, this gray one, is on the top row of the button, which is right here. Okay, we're almost there. Now the bottom row of the button connects to the minus of the battery. So looking at it here, the minus of the battery connects to the bottom row of the button, which is the minus of the battery is this black wire to the bottom row of the button. Boom. Okay. Moment of truth. Let me turn this around so you can see the fanciness of the wheel. Okay. So now when I press the button, it spins because now I got electricity going. I got a closed circuit, and if I let go of the button, it turns off. All right, so we have just built a fan now with that can be controlled by the button. All right, now Naomi has 3 buttons, so I figure, okay, so what if we want to put more buttons in it? And we wanted to get a little tricky. We want to say that the fan will only turn on if all 3 buttons are pressed, like just for fun, right? So these are different circuits. Now that all of a sudden your circuits get a little more complicated. So let's think about that. I'm going to go over back to my view over here, and I am going to erase this first circuit because we all know how that works now, right? That's the basic one. And let's try to put in more buttons, and we have to make it so that the circuit only turns on when you turn on all three. Okay? Well, we could do this. Let's see. Let's put in our battery. And we'll keep the beginning of the circuit the same. Okay? And then what I'm going to do is going to add a button here. All right. Okay, so everything's the same so far. But then check this out. I'm going to make like a train of buttons. That one's going to go like this. Okay, so what's going to happen here? You know what? I don't like to give all the answers away. So I'm going to show how to do 2 buttons. And then Naomi and the others who are watching, your job is to see if you can add 3 buttons, okay? So then check this out. This goes like this. All right, so let's talk about this. If I just press, I'm going to call this one button 1. I'll call it B1. And this is B2, button 2. The only time where I get electricity flowing all the way through, there's only one situation where I get electricity flowing all the way through, and that's when I press B1 and I press B2. I want you to kind of think about that. Why is that? Well, if I press B1 and I don't press B2, I still have electricity can't go across here if B2 is off, right? So I have to press both of them to get the circuit to flow, to get the electricity to flow. So let's go ahead and build this. All right, so we're pretty close. Let's go to my ultimate view again. My ultimate view, okay. So let's see, I have to take, you know what, sometimes it's nice to start over just so that we know what we're doing here, okay. So let's start over. This is my battery. We have the red wire here, and we're going to go purple of the motor. That goes to the same connection, the same row. Okay, so that's connected. Now the other side of the motor goes to B1. I'm going to switch things up. So I'm going to put the other side of the motor right here. I think that's row 4. Okay. That goes to the top row of B1. So I'm going to take one of my buttons, and I'm going to put it on the top row. I'm going to connect it to the top row. I'm going to connect it to the gray wire. Boom. Okay, you see what I just did? I put the button over the valley of death. That is legal. Now, what to keep in mind, though, is that I have one leg of the top row. I have like this leg right here is on this side of the valley, and this leg over here is on that side of the valley. So what that does, guys, all these holes are now all connected to all these holes over here because the 2 button legs are connecting them all together. All right, just keep that in mind. Okay, so we have that connection. Now, okay, things are getting a little tricky. The bottom leg of B1 connects to the top leg of B2. See, the bottom leg of B1 right here connects to the top row of B2. So I'm going to take my other button. I'm going to put it like this. I think that is right. Yeah. So now you can see the top row of B2 connects to the bottom row of B1. All right, and then the bottom row of B2 connects to the minus of the battery. All right, I think we're good. So let's test it out. If I just press one of the buttons, so this one's B1, right? I'm gonna press B1, no good, not working. What if I press this? If I press them both, they're both working. That's exactly what I wanted. Let's test the other way. If I press B2, no good, because I need them both, right? Press B1 now. They're both working. All right, let me turn it like this so you can see the beauty of the wheel, right? 1 and 2. All right, so there we go. Bonus information for you. This circuit right here is called, oh, let's make sure we get the black so you can see it, and circuit. So this is not used, this is used not only in electronics, this term right here, an AND circuit, it's also used in computer coding, okay? The word AND, it means you need one button and the other. So an AND circuit means you need both of the things on in order to turn on. All right, that's just some bonus information. And then it's used in coding as well, because sometimes when you code different things, sometimes you want the code to work when you have two things on rather than just one of the things. Anyways, that's a whole nother topic. So let me go back here so you can see me. All right, so hopefully that was fun and interesting. Again, if you can get the 3 buttons going, that's what I would challenge you to do. I've showed you how to do the 2 buttons. So how do you get it? How do you add to what I already showed you in the design? How do you add a 3rd button? And to make it so that I have to press all 3 buttons for the thing to turn on. Okay, so that should be an interesting exercise. All right, stay safe, take care, and I'll talk to you guys later. Bye.